Hi, fifth graders. Hope everyone's doing well today. I know my boys and I really wanted to get outside this morning, get some fresh air. So we took a run around the block a couple times, which really helped us just kind of gear up and get ready for the day today. So today I thought we would do some addition with decimals and fractions. And again, while this might be easy for you to do on paper, I really want you to challenge your brains and see if it's something you can do mentally with some mental math here. So the first problem I'm going to give you today is 5/10 plus 7/12. Sorry. Okay. So I want you to think about how you might go about solving that. Again, please make sure you pause the video if you have any, if you need some think time, and then we'll come back together. I'll share a strategy or two and see if it matches what you did. Patrick's trying over here too. So what we have for this, I'm going to go ahead and share two different strategies I might use to solve this problem. Again, see if it matches yours. I wish I could hear your thinking, but since I can't, hopefully you have the opportunity to share with someone else and then decide if you agree or not. So two ways I might do this. First of all, I know that 5/10 is equal or equivalent to 1/2. And if I'm talking about a fraction or a whole that's broken into 12 pieces, I know that half of 12 would be 6/12. So I might go ahead and just say 6/12. Sorry, I might change that into 6/12 and then add my 7/12. When I have 6 pieces out of 12 plus 7 pieces out of 12, I know that's going to give me 13/12, which of course is an improper fraction that needs to be simplified into a mixed number of 1 and 1/12. So that's one strategy I might use. Another strategy I might use is I might, again, just remember that 5/10 is equivalent to 1/2. And then when I look at my 7/12, I might remember that 7/12 is very close to my benchmark of 1/2. So I'm going to actually take out 1/2 of that. So I have to subtract 1/12, right, to be left with 6/12 here, which is equal to 1/2. So if I take out that 6/12 and add it to my 5/10, I know that's 1/2 plus 1/2, which is 1 whole. And then remember I had to take that 12th out to make it 1/2. So now I'm left with my 1 and 1/12 answer, which is the same as what I had up here. Okay. And then I thought we'd try one more, kind of similar to that. Another problem here is 25/100 plus 7/8. Again, sometimes when we see problems like this, we see, a decimal and a fraction, we might say, oh, I have no idea how to solve that. But I think you really do if you think about it. Think about your strategy you might use. So again, I'm hoping you're giving yourself a chance to try and solve these before looking at my solution. But what my strategy might be here is kind of similar to what I did on the last one. I know that 25/100 is equal to 1/4. So now I'm looking at adding 1/4 plus 7/8. And when I think about 7/8, I'm thinking about how if I had eighths, I know that 7/8 is actually very close to 3/4. I know that 6 of those eighths, sorry, you can't see there, 6 of those eighths is equal to 3/4. So what if I pulled out that 6/8? 1/4 plus 6/8, which simplifies to 3/4, is going to give me 1 whole. 1/4 plus 3/4 gives me 1 whole. And then I just have that extra 1/8 in there. So I have to add that 1/8 back in to get an answer of 1 1/8. Or if I wanted to try it differently, I could, also remember that this is 1/4 and know that in terms of eighths, 1/4 out of that eighth is equivalent to 2/8. So now I'm adding 2/8 plus 7/8, which gives me 9/8, which then again can simplify to a mixed number of 1 1/8. All right. Have a great rest of the day.
Let's compare 9.97 to 9.798. So to figure out which one of these is greater, I like to start with the largest place values and then keep moving to smaller and smaller ones until we actually see a difference. So they both have 9 ones. So at least in the ones place, they seem comparable to each other. Now let's go to the tenths place. So this number on the left has a 9 in the tenths place, while the number on the right has a 7 in the tenths place. So right now we could view this. Let's just write the whole numbers out. So this one is 9 plus 9 tenths. We haven't gone to the hundredths place yet. So far, out of the two digits, the two places we've looked at, this one on the right is 9 plus 7 tenths plus 7 plus 7 tenths. So this immediately cues to me that the one on the left is a larger number. You're like, hey, how do I know immediately that's the larger number? I have all this other stuff to the right. I have this 9/8 to the right. I have this 7 to the right. And the way to think about it is, no matter what you have, even if you really increase this right-hand side here as much as possible, you're still less than 9.8. In fact, if you keep incrementing the thousandths here, you go from 9.798 to 9.799 to 9.8. So you would have to actually increase to get to even 9.8, and this is at 9.9. So you can really just look at the discrepancy in the largest place value to recognize which number is greater. This has 9 tenths. This has 7 tenths. It doesn't matter what's going on in the hundredths and the thousandths place. And to make that clear, let's actually add up these numbers and compare them as fractions. So let's keep on going with this. So you have 7 hundredths here. So you have 7 hundredths here. And here you have 9 hundredths. So here you have 9 hundredths. And then finally, here you have 0 thousandths, and here, let me do that in a different color. I already used blue. And here you have 8 thousandths. So plus 8 over 1,000. So let's put everything in terms of thousandths so that we can add these all up and have fractions or have two fractions over thousandths, or things in terms of thousandths. So 9 is the same thing as 9,000 over 1,000. 9 tenths, well, let's see, if you multiplied it by 10, you'd get 90 over 100. Multiply by 10 again, you get 900 thousandths. 7 hundredths multiplied by 10 is 70 thousandths. And let's do that over here. Once again, 9 is 9,000 over 1,000. And then plus 700 over 1,000, plus 700 over 1,000, plus 90 over 1,000, plus 90 over 1,000. Just multiply the numerator and denominator by 10, plus 8 over 1,000, plus 8 over 1,000. And so what is this number on the left? This number on the left is, how many thousandths is it? It's 9,907. Sorry, 9,970. So it's 9,970 thousandths, while this number on the right here is, 9,798 thousandths. So here, once again, you're comparing two numbers. They have the same number of thousands. This has 900. This only has 700. So even though this is almost 800, 800 is still less than 900. So no matter how you think about it, the number on the left is greater than the number on the right.